Okay, so let's extract information then. So do we know F1 and F2? What's F1? The initial velocity, the initial angular velocity, 3,000 RPM, which is 50 hertz. The final angular velocity, the angular acceleration, minus 10, right. It's not a major issue, this, which way you get it around. It's just that it will mess signs up if you get it the wrong way around, yeah. Which formula is going to be useful for part A? So we want the time for the rotor to stop revolving. What formula did he use? Which is? Omega 2, yeah. Right. Rearrange for time. So what does time equal? Over alpha. Yeah. Don't forget this could be delta t, okay? In other words, the time for this to happen. The time over which it's accelerating. It's accelerating uniformly, so we know it's going to, if we plotted a graph, it will be a straight line. But we don't know omega 2 and omega 1. Well, so what we can do is we can work out what they are. In fact, we can think of them as 2 pi times. We can leave it like that. So we can say delta t equals omega 2, which is 0, minus omega 1, which is 2 pi times 50. I can think of it like that. That is omega 1 over alpha, which is minus 10. So delta t equals minus 100 pi over minus 10. And the minuses cancel out. Minus minus gives us a plus, so that is going to give us a positive time, thank goodness. Okay, so that's 10 pi. I could leave the answer in terms of pi, because as soon as I start working it out, I'm going to get a decimal, aren't I? I'm going to be rounding. I could leave it as 10 pi seconds. But if I want to actually know what that is, well, I'd work it out. Times that by pi, it's about 31 point something, 31.4 seconds. But it might be worth leaving it as 10 pi, particularly if I'm going to carry on and put that value into the second part of the problem. So the time for part A, 10 pi seconds. What about part B then? The number of revolutions made while coming to rest. So for part B, I need the number of revolutions. Do we know a formula for the number of revolutions? N equals theta over 2 pi. I'm already thinking to myself, I've got a pi here, and if I've left my time in terms of pi, maybe later on they'll cancel out. That's going in my head. I don't often get rid of the pi because they might cancel out. Well, do I know theta? If not, can I work it out? Is there a formula that will allow me to find out what theta is? In our list of formula is a formula that might help here. Where are we? Have we gone back too far? Where's my formula sheet going? Theta equals? Okay, The total angle turned is the average angular velocity, omega 1 plus omega 2 over 2, times by the time taken. We know omega 1, we know omega 2, and we know the time. So n equals theta over 2 pi. So it's going to be a half omega 1 plus omega 2 t over 2 pi. I could write it like that. If you want to, you can work it out at each stage. That's perfectly acceptable. So work out what theta is here and then divide your answer by 2 pi. Or, if you're feeling confident, put it into one big formula. There's my formula for the angle. Divide that by 2 pi. Up to you. But if I leave it like this, there's a chance that some of these pi's are going to cancel out, which will only help. A half omega 1 was 2 pi, well in fact 2 pi times 50, wasn't it? Omega 2 was 0. Time is 10 pi seconds. We just worked that out over 2 pi. Yes, this 10 pi is the time we got from part A, isn't it? So that's t, 10 pi. Note that pi's cancel here. 2's goes into 2 once, 2's goes into 10 5 times. So we've got 5 times a half, 5 halves of 2 times 50 is 100 pi. That's what it comes out to be. Simplifying it down. So that's 250 pi. The number of turns. And if you want that as a figure, then you'd work out what 250 times 3.142 is.